Good morning, everyone. Myself, Rohit Kulkarni. First of all, I welcome you for today's session. As you know, we are going to see lesson number 2, periodic classification of elements of science 1. Right? We are going to continue this topic. Just before starting, I just want to revise some of the points what you have seen. In the last 3 periods, you have seen about how the elements are classified, what are the types of matters, elements. Then you have studied about of octaves. That about mental spirits, you have studied modern law. You stop saying form of the periodic table. So number 21. Your textbook, you can open page number 21 of your. See what is modern periodic table. The classification of elements resulting from an arrangement of the elements in an increasing order of the atomic number in the modern periodic table. As you already seen that the modern periodic table is made up of based on increasing order of the atomic numbers.
Hello, Rohit sir.
So we are going to see. Yes, ma'am.
Rohit sir. सर
hello.
तुमचा आवाज क्लिअर येत नाहीये. थोडा डिस्टर्बन्स असं वाटतं, आवाज क्लिअर येत नाहीये.
ओके चालेल. आता hello. So the classification of elements resulting from an arrangement of the elements in an increasing order of their atomic number in the modern periodic table. The properties of the elements can be predicted more accurately with the help of the modern periodic table formed on the basis of atomic number. So whatever the properties of elements are there, right? As we know, total 118 elements are known till now. Out of that, we are going to study only first 20 elements. So whatever the properties of each and every element that we are going to predict with the help of this modern periodic table, which is based on the atomic number. The modern periodic table is also called the long form of the periodic table, right? As heading itself, it is given the modern periodic table. The other name for modern periodic table is long form of the modern periodic table. Now, see, in the modern periodic table, the elements are arranged in accordance with their atomic number. Right? We have gone through the modern periodic table, which is on page number 23. Right? You have seen the element. Just I will tell you the name of some of the elements like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Clear? Then apart from that, sodium, magnesium. So you have gone through all the elements. So whatever the elements are arranged in the modern periodic table, they are arranged with the help of the atomic number. As a result, most of the drawbacks of Mendeleev's periodic table appear to be removed. So already we have studied that whatever the drawbacks was made by the Mendeleev's periodic table, it is totally removed in this modern periodic table. However, the ambiguity about the position of hydrogen is not removed even in the modern periodic table. So still in modern periodic table also it is seen that what place to be given to the hydrogen element. So still that it is ambiguity in the modern periodic table. We have seen in the previous standard that the electron configuration of an atom, the way in which the electrons are distributed in the shells around the nucleus, is determined by the total number of electrons in it. And the total number of electrons in an atom is same as the atomic number. So already we have studied that total number of electrons in an atom means its atomic number. Now just for example, Suppose there are 8 electrons. 8 electrons means the atomic number of that element is oxygen. Clear? Suppose the number of electrons are 10. It means the atomic number of that element is 10 and the element will be neon. So in this way, if you know the number of electrons, we can find out the atomic number, and even we can find out its valency. So that we'll study further how to find out the valency of the elements. The relationship between the atomic number of an element and its electronic configuration is clearly seen in the modern periodic table. So in modern periodic table, we can see the relationship between the atomic number of an element and its electronic configuration. So we are going to see that how to write down the electronic configuration of different elements if you know the proper atomic number. So that all in details we are going to see today. Clear? So this is about what modern periodic table or long form of the periodic table. Hope so all of you have understood the basic information. Now we'll move on the main point, that is structure of the modern periodic table. Means how the modern periodic table is designed. See, the modern periodic table contains 7 horizontal rows called the periods 1 to 7. Right? So you remember this, the modern periodic table, it contains 7 horizontal rows called the periods 1 to 7. So first, similarly, the 18 vertical columns in these tables are called groups, and that is 1 to 18. So in short, the horizontal rows, they are called as periods, and the vertical columns are called as groups. So the periods are numbered from 1 to 7, and the groups are numbered from 1 to 18. So further, I will show you one periodic table. In that you can find out which are the periods and which are the groups. The arrangement of the periods and groups results into formation of boxes. So whatever the arrangement of periods and the groups are there, they are result in the formation of boxes. Now, the atomic numbers are serially indicated in the upper part of these boxes. Each box corresponds to the place for one element. So whatever the atomic numbers are there, they are serially indicated in the upper part of the boxes, which is shown on page number 23, the table, modern periodic table. And each box, so you can see the total different boxes are there. So each box corresponds to the place for one element. Now, for example, hydrogen. So that is, especially it is hydrogen. If you see, for example, magnesium, the atomic number is 12. So a special place is given for that, and it means that is magnesium. So atomic number will be 12. Now, apart from these 7 rows, 2 rows are shown separately at the bottom of the periodic table, and these are called Lanthanide series and Actinide series. Right? Just I will show you the periodic table, means you will understand. Just see the right. So the special. So these are called Lanthanide series and Actinide series respectively. So apart from the 7 rows and 2 rows are shown separately at the bottom of this periodic table. So they are called as Lanthanide series and Actinide series. And also they are called as what? They are called as F block elements. There are 118 boxes in the periodic table, including the 2 series. So as I told you, till now, total 118 elements are known. It means what? In modern periodic table, there are total 118 boxes, right? Including 2 series, means the Lanthanide series and Actinide series. So total all over, there are 118 elements are known. Very recently, formation of few elements was established experimentally, and thereby the modern periodic table is now completely filled, and all the 180 elements are now discovered. So till today, total all whole modern periodic table is completely filled. Until now, total 180 elements are discovered, and each and every element is known. Now, see the entire periodic table. So the entire periodic table is divided into 4 blocks, that is S block, P block, D block, and F block elements. So entire periodic table, it is divided into 4 types or 4 blocks. We can say S block elements, P block elements, D block elements, and F block elements. Now see the S block elements contains the group 1 and 2. So remember, the S block elements contains the group 1 and 2. Then the group 13 to 18, right? Just look in the modern periodic table. The group 13 to 18, it constitutes the P block elements. Then from group 3 to 12, it constitutes the D block elements, while the lanthanides and actinide series, they are at the bottom, form the PF block elements, right? So the entire periodic table, it is divided into 4 blocks: S block, P block, D block, F block. Clear? So the S block contains the group 1 and 2. Total 18 groups are there. Clear? So out of that, the group 1 and 2, it is constitute the S block. Then group 3 to 12. Group 3 to 12, it constitutes the D block elements. Group 13 to 18, it constitutes the P block element. And at the bottom, the two series which are present, that is Lanthanide series and actinide series, they constitutes of F block elements. Clear? Then the D block elements are called transition elements. So the D block elements means the group 3 to 12. So whatever the elements are there in the D block elements, they are called as transition elements. Clear? Then if you see in the modern periodic table, there will be one zigzag line from element number 13. So a zigzag line can be drawn in the P block of the modern periodic table. The three traditional types of elements can be clearly shown in the modern periodic table with the help of zigzag line. So we'll see in details what is the meaning of this zigzag line. Now see, the metalloid elements lie along the border of this zigzag line. So whatever the metalloids are there, right, they lie along the border of this zigzag line, because in the modern periodic table, all the elements are divided into 3 types: metals, non-metals, and metalloids. So the metalloids, the elements lie along the whatever the border is there of the zigzag line. Remember this: all the metals lie on the left hand side of the zigzag line, while all the non-metals lies on the right hand side of the zigzag line. So this is the most important thing you should remember, that whatever the metals are there, they lie on the left side of the zigzag line, and all the non-metals lie on the right side of the zigzag line. Yeah, so this is about what? Structure of the modern periodic table. Clear? So just I will show you the so you can see this figure, that is modern structure of the modern periodic table, right? So if you see, total 18 groups are there and 7 periods are there. So the first two groups, they are, as we have seen, they are S block elements. Then group 3 to 12, they are D block elements. Then group 13 to 18, they are P block elements. And at the bottom, the two series are there, that is Lanthanide series and actinide series, they are called F block elements. Clear? So hope so all of you understood this point. Now we will move on the next point, that is modern periodic table and electronic configuration of elements. As I told you, we'll see the how to write down the electronic configuration. So each and every student should know the atomic number of the element, it's how to write the electronic configuration, and its valency, because these are the most important points, because so many questions can be asked from this part. Now see, the next point is modern periodic table and electronic configuration of elements. Now see, within a period, the neighboring elements differ slightly in their properties, while distant elements differ widely in their properties. Elements in the same group show similarity and gradation in their properties. So you can see the elements in the same group, they show the similarity and the gradation in their properties. And these characteristics of the groups and periods in the modern periodic table are because of the electronic configuration of the elements. Right? So these characteristics of the groups and periods in the modern periodic table, it is because of the electronic configuration of the elements. It is the electronic configuration of an element which decides the group and the period in which it is to be placed. So this is the most important thing. The electronic configuration of element will decide the group and the period in which it has to be placed. So if that is why, as I told you, you should be able to write the electronic configuration of each and every element. Now we'll see some of the characteristics of groups and periods. The characteristics of the groups and periods in the periodic table are understood by comparison of the properties of the elements. Right, so whatever the characteristics are there of the groups and periods, they are understood by comparing the properties of each and every element. Various properties of all the elements in a group show similarity and gradation. However, the properties of element change slowly while going from one end to the other end, particularly from left to right in a period. Right. So what is given? The whatever the properties of elements are there, they changes slowly while going from left to right, or that is from one end to another end in a particular period. So as we move in a particular period, the properties changes from one end to the another end. So this is about the characteristics of groups and periods. Clear? Now, if you see on page number 22, one activity is given. So that activity we are going to see now. So if you have textbook, you can open page number 22. Just we'll go through that activity, which is very important. So groups and electronic configuration. Now see, what is the first question? Can you tell? Go through the modern periodic table 2.7 and write the names one below the other of the elements of group 1. Right? Now we are going to write the elements of the group 1. So which are the elements? Hydrogen, lithium, sodium, potassium. Clear? So we have written the name of the elements. So 4 elements of group 1 are hydrogen, lithium, sodium, and potassium. Then after that, write down the electronic configuration of the first 4 elements in this group. Now see, hydrogen, atomic number is 1, so the electronic configuration is 1. Then second element is lithium, atomic number is 3, its electronic configuration is 2, 1. Then third element is sodium. Atomic number is 11. Its electronic configuration is 2, 8, 1. The next element is potassium. Its atomic number is 19. Its electronic configuration is 2, 8, 8, 1. Clear? As I told you, we are going to see electronic configuration of some of the elements. So here we have seen 4 elements. The first one is hydrogen, lithium, sodium, potassium. So if you know the atomic number, you can write down the electronic configuration easily, because in first shell there are only 2 electrons, and in the second shell there are 8 electrons. So we'll see further that how to write down the electronic configuration. So what is the third question? Which similarity do you find in their electronic configuration? Now see, what is the similarity? The similarity is observed in valence electrons of these elements, and the valence electrons in these elements is 1. Just I will show you the last slide. Now if you see, in each and every element in last shell there is 1 valence electron. Clear? So that is the similarity observed in these elements. So what is the similarity observed? The similarity is observed in valence electrons of these elements. The valence electrons in this element is 1. So in the last shell there is only 1 electron is present. Let's see what is the fourth question. How many valence electrons are there in each of these elements? So there is only 1 valence electrons in all of these elements, because in the last shell, clear, you can see only 1 electron is present in all the 4 elements such as hydrogen, lithium, sodium, and potassium. Clear? So this is about the activity. Can you tell? Clear? Now see, after going through this activity, what we'll see? You will find that the number of valence electrons in all these elements from the group 1, that is family of alkali metal, is the same, right? So after doing this activity, what we have seen that the number of valence electron in all these elements means from group 1, hydrogen, lithium, sodium and potassium, the family of alkali metals, so we call them as the alkali metals, is the same. Similarly, if you look at the elements from any other group, you will find the number of their valence electrons to be same, right? So one more example we are going to see of the another group. So for example, so we'll see the elements of the second group like beryllium, magnesium, calcium. Clear? To the group 2, that is they are family of alkaline earth metals, right? So the first group is alkali metals, second group is a family of alkaline earth metal. So here 3 examples are given, that is beryllium, magnesium and calcium. So the atomic number of beryllium is 4. Its electronic configuration is 2 2. Then atomic number of magnesium is 12. Its electronic configuration is 2 8 2. Then next element is calcium. Its atomic number is 20. Electronic configuration is 2 8 8 2. Clear? Now if you see in each of these elements in outermost shell there are only 2 electrons, because they are in the group number 2nd. Now see, there are 2 electrons in the outermost shell. As I told you, there are 2 electrons in the outermost shell. Similarly, there are 7 electrons in the outermost shell of the elements such as fluorine. Now we'll see the next example, that is fluorine, chlorine. Yeah, so with the group number 18, this if you see group number 18, the atomic number of fluorine is 9, so its electronic configuration is 2 7. Then atomic number of chlorine is 17, its electronic configuration is 287. So if you see in the outermost shell there are 7 electrons are present. So that is the family of halogens. So we call them as fluorine, chlorine, bromine, iodine. So these all are what they are called as halogens. Clear? Now, while going from top to bottom within any group, so we have seen from top to bottom. Clear? Because in the first example we have seen of hydrogen, lithium, sodium, potassium. Then second example we have seen of beryllium, magnesium, calcium. And third example we have seen of fluorine, chlorine, and bromine. So we have moved from top to bottom within any group. One electronic shell gets added at a time. From this, we can say that the electronic configuration of the outermost shell is the characteristics of a particular group. However, as we go down in a group, the number of shells goes on increasing. So this is the most important time. As we go down in a group, what happens? The number of shells goes on increasing. Clear? So this is about what groups and electronic configuration. So we have seen the activity and also we have seen some of the examples of group 1 alkali metal, group 2 alkaline earth metal, and group number 17, that is halogens. Clear? Now, in the modern periodic table, after doing this activity, what are the things we have understood? In the modern periodic table, elements are arranged in an increasing order of their atomic number. So this is the most important thing, that whatever the elements are arranged in the modern periodic table, they all are arranged in the increasing order of their atomic number. Now, as we have seen, vertical columns are called groups. Right? Already we have seen that whatever the vertical columns are there, they are called as groups, and there are 18 groups. And the chemical properties of the elements in the same group show similarity and gradation. So whatever the chemical properties of the elements are there in the same group, they show the similarities and also gradation. Then third point, horizontal rows are called periods. So whatever the horizontal rows are there, they are called as periods, and there are total 7 periods. So there are in all 7 periods. The properties of elements changes slowly from one end to other end in the period. So this is the difference. So the properties of the elements, they changes from one end to other end in the period as we move from left to right. Right. So this is about what modern periodic table. Now see, do you know uranium has atomic number 92? Right, so you can see if on page number 23, the modern periodic table is given. So that is in the actinide series, the uranium has atomic number 92, all the uranium. So whatever the elements which are present, they are man-made. All these elements are radioactive and unstable and have a very short life. So whatever these elements are there, they are radioactive, they are unstable and have a very short life. Clear? So this is an extra information given about uranium. Clear? So once again, just I will repeat, uranium has atomic number 92 and all the elements beyond uranium with atomic number 93 to 118, they all are man-made. And all these elements, they are radioactive elements and they are unstable and they have very short life. Clear? So this is about for you. Now see, if you come on page number 21, there is one activity is given, use your brain power. So that we are going to see now. So it is position of elements in the periodic table, right? That is the point we have not seen. So we will see that point, page number 21, use your brain power. Now see, some questions are asked. The first question is, how is the problem regarding the position of cobalt and nickel in Mendeleev's periodic table resolved in the modern periodic table? Right. So this is the first question. How is the problem regarding the position of cobalt and nickel in Mendeleev's periodic table this solved in the modern periodic table? So see here, Mendeleev arranged the elements in their increasing order of atomic masses. As you know, in the last video, the Mendeleev, what he has done, he has arranged all the elements in the increasing order of their atomic masses. But whatever the modern periodic table is there, it is arranged according to the increasing order of atomic number. Clear? So, but some elements with higher atomic masses are placed before those having lower atomic masses. So, what happened? Some of the elements in the Mendeleev's periodic table, it is with higher atomic masses are placed before those having lower atomic masses. So for example, cobalt with atomic mass 58.93. So the atomic mass of cobalt is 58.93 is placed before nickel having atomic mass 58.71. Here, because in Mendeleev's periodic table, it is arranged according to the increasing order of atomic masses. So what should happen? The nickel should be placed before then the cobalt. But actually, what happened? The cobalt is placed before. Its atomic mass is 58.93, which is greater than the nickel. So modern periodic table was prepared on the basis of the atomic number of elements. So the atomic number of cobalt is 27, and that of nickel is 28. So nickel is placed after cobalt. Clear? So in this way, in modern periodic table, the problem regarding the position of cobalt and nickel is resolved. Clear? Because in modern periodic table, the atomic number all the elements are arranged according to the increasing order of atomic number. So the atomic number of cobalt is 27 and that of nickel is 28. So first the nickel is placed and then after that there is cobalt. Clear? So this is the explanation for the first question. Now, second question. How did the position of chlorine, that is isotopes, get fixed in the modern periodic table? You can see Cl 1735, then 17 is atomic number and 35 is atomic mass, then 1737. Now see what is the explanation for this. In Mendeleev's periodic table, the differences between atomic masses of two consecutive elements is not the same. So you can see two elements are there with atomic mass 35 and atomic mass 37. Clear? But the atomic number is same. Mosley found out the atomic number of the elements. So as we have already studied that Mosley, what he has done, he has found out the atomic number of the elements. The atomic number of any element is increased by 1 unit. You have seen the atomic number of any element, it is increased by 1 unit. Clear? Hydrogen, the atomic number of hydrogen is 1. If you see the atomic number of helium is 2, so it is increased by 1 unit from the atomic number of the subsequent element. Now before that we'll see what is isotopes, because these are the isotopes. Chlorine. So chlorine 1735 and chlorine Cl 1737, they occupy the same position in the modern periodic table, right? Both are isotopes. Both isotopes have the same atomic number. As I told you, the atomic number of chlorine is 17, but they have the different atomic mass. Clear? So they have the same position in the modern periodic table. In the modern periodic table, the elements are arranged in the order of their increasing atomic numbers. That the problem of discrepancy in the pairs of isotope elements observed in the Mendele's periodic table was solved. Therefore, the isotopes of chlorine 1735 and 1737 were placed in the same group, as both have the same atomic number. So, what is given in the modern periodic table, the elements are arranged in the order of their increasing atomic numbers, and that the problem of discrepancy in the pairs of isotopes is observed in the Mendele's periodic table. But in the modern periodic table, it is not observed. That is why both the isotopes of chlorine, they are placed in the same group. Why they are placed in the same group? Because they have the same atomic number, that is 17. Clear? So this is the explanation for the second question. Now we'll see the explanation for the third one. Can there be an element with atomic mass 53 or 54 in between the two elements, chromium and magnesium? So what is the question given? Can there be an element with atomic mass 53 or 54 in between the two elements, chromium and magnesium? Clear? Now see the explanation for this. In Mendele's periodic table, the difference between atomic masses of two consecutive elements is not the same. Remember this. In Mendele's periodic table, what you see, the difference between atomic masses of two consecutive elements is not the same. So the example is given of chromium and magnesium. Mostly found out the atomic number of the elements. The atomic number of any element is increased by 1 unit. As we have seen already, the atomic number of any element is increased by 1 unit from the atomic number of the subsequent element. So the chromium 2452 and manganese 2555, that means between two elements, chromium and magnesium, elements with mass 53 or 54 do not exist, because atomic number of chromium is 24 and atomic number of manganese is 25. So they are subsequently, means they are continuously, there is a difference of 1 unit or 1 number. So from this we can say that the elements with mass 53 or 54 do not exist in between chromium and manganese. Clear? So understood why the atomic mass 53 or 54 cannot exist between the chromium and manganese, because the atomic number of chromium is 24 and atomic number of manganese is 25. So according to Mosley, the atomic number of any element is increased by 1 unit or 1 number. So therefore, this atomic mass is 53 or 54. They cannot be exist between chromium and magnesium. Then the fourth question. What do you think? Should hydrogen be placed in the group 17 of halogens or group 1 of the alkali metals in the modern periodic table? Because already we have seen there is still ambiguity about the position of hydrogen. Even in the, it's not removed even in the modern periodic table, but still now, for now, we are placing the hydrogen in the group first, which is the atomic number 1. Now see what is the answer for this. Hydrogen is placed in group 1 and in group 17, as it resembles alkali metal as well as halogen. Clear? So hydrogen is placed in group 1 and in group 17, as it resembles the properties of both alkali as well as the halogen. Thus, no fixed position was given to hydrogen in the modern periodic table. So in in Mendele's periodic table, hydrogen has not given a fixed position because it possesses the properties of both alkali metals as well as the halogens. On the other hand, but in the modern periodic table, what happened? The fixed position is given. On the other hand, hydrogen easily donates the electron and forms a stable cation. Clear? But it does not easily form a stable anion. So remember this, hydrogen can donate 1 electron and forms a stable cation, that is H plus, but it does not easily form a stable anion, that is H minus hydrogen. Hence, it is better placed in group 1 rather than in group 17 in the modern periodic table. So that is why it is better. It means hydrogen is placed in the group 1 rather than in group 17 in the modern periodic table. So that is why in modern periodic table, the hydrogen is placed in the group 1 and the atomic number of hydrogen is 1. So hydrogen, what it can do easily, it can donate 1 electron and it can form a stable cation H plus, but it cannot form a stable anion. Clear? So this is about what position of elements in the periodic elements. Clear? So hope so all of you understood all the 4 questions. So this is about today's point. So what we have seen about modern periodic table and long form of the periodic table. Clear? How the elements are. Then we have seen the structure of the modern periodic table. What is the meaning of group, periods? What is groups? Its definition. Then which are the elements? Then different elements: S block, P block, D block, F block elements. Then S block contains the group 1 and 2. Then groups 13 to 18 constitutes of P block elements. Then we have seen that group 3 to 12 constitutes the D block element, and the Lanthanide and Actinide series, they are present at the bottom of the periodic table. They are called as F block elements. Then we have seen one zigzag line. On the left hand side, all the metals are present. On the right hand side of the zigzag line, all non-metals, and the zigzag line means all the metalloid elements are present. Then afterwards, we have seen the characteristics of groups and periods. And we have seen one of activity, that how can we write the electronic configuration of different elements. And then again more examples we have seen from group number 1 about hydrogen, lithium, sodium, potassium. Then we have seen example of alkaline earth metal, then like for example beryllium, magnesium, calcium, and also we have seen the example of group number 17, that is halogens, fluorine, chlorine. And from that what we have seen that the last shell has the same number of electrons. So we have seen all the 4 questions, that's position of elements in the modern periodic table. So hope so all of you have understood all the points. Clear? Now just what you have to do, you have to answer some of the questions. Whatever points we have seen from page number 21 and 22, we have seen the 2 pages. From that you have to evaluate. So the first question is define groups. So if any students, those who know the answer, only first one, answer for the first question, define groups. Those who know the answer, they can raise your hands. Define groups. Hello ma'am, can you unmute the students, those who know the answer?
Students, unmute yourself and answer.
Only answer the first question. Define groups. You can answer it.
Hello,
Those who hello. You can answer the first question. The first question is define groups. You have to tell the definition. Hello. Hello. Hello, ma'am.
Hello, yes, sir.
Is any students answering the question whether they have raised their hand?
They are raising their hand, but they are not unmuting yourself. They are
Okay.
raising their hand, sir, but they are not asking anything. Alicia and Tejas Swimming. Both of you are raising your hands. If you are having any doubts, please ask.
सर अभी जो
हेलो
क्वेश्चन
सर
आंसर दिखा है वो सब
हाँ.
क्वेश्चन आएगा
हेलो
क्या
सर
पेपर में?
One of you just speak one at a time. You can ask. Hello.
हेलो सर,
हाँ.
अभी जो आपने क्वेश्चन आंसर दिखा है वो सब पेपर में आएगा क्या?
Yeah, this is a part of evaluation. You can answer this. This question can, such type of questions can come for the exams. This is a part of evaluation, right? Whatever the topic we have seen today, on depending on that, we are just evaluating. Now that
Hello,
is the first question. Define
hello,
groups.
हेलो सर
Hello.
Sir, define groups or define periods, how many groups and periods.
हेलो सर
सबका मीनिंग्स लिखना है क्या?
अरे यार
See here, just wait. मैं बता रहा हूँ आपको groups की definition लिखना है, right?
Hello,
Vertical
sir.
columns are called groups. Wait. Let her complete first, then I will. Just
हेलो
wait.
सर
हाँ, continue. Speak.
how many groups are the period in the there of the modern of the period table? सर उसका आंसर बी ब्लॉक सी ब्लॉक डी ब्लॉक उसका बताना.
No. नहीं वो you can say total how many groups are there. You can say 18 groups and 7 periods. How many groups? 18 groups and 7 periods are there in the modern periodic table. And then further they are divided into 4 groups, that is S block elements, P block elements, G block elements and F block elements. And just I asked how many groups are there. So there are 18 groups and 7 periods. Clear? Then fourth question is name the elements having atomic number 11. So if any students know the name of the element having atomic number 11, they can tell the answer. You can find out from the periodic table and you can just tell me what is the name of that element having atomic number 11. Any students know the answer for that? Name the element having atomic number 11. Okay, if you don't know, I will just tell you the answer for that. The element having atomic number 11, you can find out for that. And the last question is say the electronic configuration of element oxygen having atomic number 8, right? So you have to write down the electronic configuration of the element oxygen. So the electronic configuration for the oxygen is 2, 6. Yeah. So these are some of the questions you can write down and you can find out the answer for that and you can study that. Clear? And once again, you can revise page number 21 and 22. And tomorrow in the next period, we'll continue from the next point, that is periods and electronic configuration and how to write down the different things in the modern periodic table. So tomorrow we'll continue. Okay. Thank you, students. If any students have any doubt, they can ask. Otherwise, we'll wind up our lecture.
Still, 2 students are raising their hands. Do you want to ask anything? Okay, sir. We can stop here.
Okay, ma'am. Thank you.
Okay.
Thank
Thank you
you,
so
students.
much.
Thank you.